the optimization of stuff right here. We said, first of all, try to understand what you're trying to optimize. That was the first tip. We said, secondly, if it's to your advantage to make a sketch of this, you may want to do that. Okay? Third, then, we said try to write what you're trying to optimize in terms of how many variables, kids? One. Okay, we typically start out stuff with 2 variables, but we need to rewrite it in terms of 1. Once you've got it written in terms of 1 variable, we're looking for critical points. So first derivative, set it equal to 0 and solve. And, you know, I felt pretty good about what we were doing. The process was kind of the same. So we'll get started on this first one right here. We talked about yesterday saying, always write down what you know first. You always want to write down what you know. Okay? So I'm going to put that right there. What do we know? And then secondly, we're saying, well, what are we trying to optimize here? What are we trying to optimize? And then once we've optimized this right here, we put our solution down. Okay? So we'll put our solution down here. So, let's see what happens here. How about a volunteer to read example 5 for me?
You have 800 feet of fencing and want to enclose a rectangular area up against a long wall. What is the largest possible area you could enclose?
Okay, so the assumption right here, guys, is what type of a shape?
A rectangle, but there's a wall.
Exactly.
So
We know we're dealing with a rectangle. So it's like you have this fencing right here, kids. Okay, and along this right here, there's like a wall. So we're using, I'm going to kind of draw a line in here as best I can. Let's just say that there's a line right here that's extended. Okay, so it's kind of like this longer line up here. This is like the wall of a building that we're going to go ahead and we're going to make an area, but one side of the area is not going to be like fencing. It's going to be a what? It's a wall. So do you guys agree that we're really talking about how many sides of fencing in this problem?
3.
We're really talking about 3 sides. We have a side, right? Maybe here's a fenced side. Here's a fenced side. So I'll just put little dashes through it like this to indicate, yeah, that's where my fence is. Okay, we're trying to say, what's the best way so that we can maximize this area right here? We want to know what's that area as a maximum, okay? Now guys, the 3 sides that are red, we know that they're going to add up to how many feet of fencing? 800, okay? So I'm just going to do this. I'm going to go ahead and put an X right here. I'm going to put a Y down here. I'm going to put an X over here, okay? So we have these sides. One side is X right there. This side is Y right here, and this side is X. All agreed there?
Yeah.
Okay, guys, in terms of what we know based on our sketch, is there a possible equation we could write for what we know given the length of the fencing on 3 sides?
Yeah.
What would the equation be for what we know here?
2x plus y equals 800.
2x plus y must equal 800. Okay, show of hands, how many agree with that? Okay, now, we've kind of got the stuff set up that we already know. Now, what are we trying to optimize, kids? What are we after here?
Maximum value.
We want the maximum, in this case, largest possible, what here? Now, I told you guys yesterday, you're going to have to know some area formulas. Some of them, if you're going to be easy to remember. Some of them, if you don't remember, where are you going to look them up at? Google them, okay? Guys, we're talking about the area of a rectangle right here, so based on our parameters down there, area would equal what 2 variables times each other? X and Y, right? So we have this area that we're trying to optimize dependent upon 2 variables, X and Y. Do I want that to be dependent upon 2 variables, or do I want to try and rewrite that so it's dependent upon 1? Okay. Now guys, can I give you a hint on this today? Okay. Go down to what we know, because we would change some things for what we know. Guys, between the 2 variables from what we know, what would be the easiest variable to get alone?
Y.
Okay, let's talk about this. From what we know, let's get y alone. What would y equal if we go ahead and manipulate that?
800 minus
Okay, so guys, if y is equal to 800 minus 2x, here, what could y get replaced with in this situation?
Students going on Mr. Loftus's field trip, please report to the office at this time. Students going on Mr. Loftus's field trip, please report to the office.
C-Mac, you going?
800.
You going, man, or not? Okay.
800 minus 2x.
Okay, now I want you to think about this, guys. My area now that we're trying to optimize becomes that value x times our replacement. Anytime we substitute, we should always put what around our substitution? Okay, let's go ahead and distribute the x to both of those terms. Wouldn't this be 800x minus 2x squared, friends? All agreed? Now kids, I want you to think about the function we've just written there, okay? First of all, what degree is that function? What's the highest power? 2. This is like an x squared. So you agree this is a quadratic, right? Guys, what kind of x squared do you have? A positive or a negative x squared? When you graph quadratics, are either a parabola, a U shape, or an arch shape. Is this going to be a U shape or an arch shape? It's going to be an arch because there's a negative out in front of the x squared, right? And if I have an arch, is that indicative of a maximum point or a minimum point? Maximum point. You will know you're kind of on the right track right here. Say, yeah, I've got a function that's going to give me a maximum point. What are we looking here, kids, for?
Looking for the largest possible.
Okay, so does it make sense that we're probably going to end up with a maximum based on our graph or our function that we're dealing with that we're about ready to optimize? Okay, so guys, it just becomes that game then. Find the critical point for this. So we're going to find the first derivative of this. A prime equal to what?
800 minus 4x.
And then once you've got your derivative, to find a critical point, we got to set that equal to what value, friends?
0.
And it becomes a matter of solving for x. So we're at this point where 800, I'm going to add 4x to both sides, would equal 4x. I don't know, you tell me about my north of Highway 3 math skills. What's 800 divided by 4?
200.
200, right? X equal 200. 200 laps in the Daytona 500. Oh, never mind. Gracie, you were gone yesterday. I had a really good joke for the kids and you missed it. Should I tell it to her again, kids?
No, I'm kidding.
It was a good one, wasn't it? It was the one where I got asked to name 2 structures that hold water. And I thought to myself, well, damn. You like that one?
That's pretty good.
Alrighty then.
That's pretty good.
Did I tell that to you yesterday? I did, didn't I? Gibby never forgets a good joke. Gibby, did I tell that one?
Yeah.
Alright. Hey, help me out, friends. What's x equal to?
400.
How much?
X equals, 200.
200. You're ahead of me right now, okay? Guys, go over here. Once I know x, that's going to allow us to solve for what here, friends?
Y.
Y. So I would come down here and say, well, you know what then? That's true. Then y must equal 800 minus 2 times 200, right? What's that going to be?
400.
There you go. Now guys, I want you to put a note on number 5. I want you to put like a be careful note on example 5. Okay? You know that this x value right here is, what did we say, 200? And you know that this y value we just said right here is 400, isn't it? One thing about optimization problems, and it could probably be another tip. If I had to say there's a 5th tip that we didn't put in the notes, if there was a 5th tip to this, always go back to your optimization questions and ask yourself, what is it they really want to know? Yeah, we found some dimensions. X is 200, Y is 400. Does that necessarily mean we're done with the question? Well, maybe if the question says, what are the dimensions that get you the largest possible area? But reread the question up top here, kids.
What's the largest possible
They
area?
want to know, what is that area? Okay. Well, I've got X is 200, Y is 400, but does that tell me what the largest possible area is? No, but would that be useful in helping us find the largest area? Okay, so what are you going to do with 200 and 400 to find that largest area?
Multiply.
Multiply, so, I don't know. So the largest area is 200 times 400. what is that, 80,000? And then what was that? Were we in meters or feet or?
Feet.
Feet, which is 80,000 square feet. So guys, if I give you 800 feet of fencing and say you gotta make a rectangle, and you can use one side of a building to do that, the biggest area you can enclose in a rectangular would be what? 80,000 square feet, okay? Alright guys, so if I back up here for a second, if I go to page 1 again, and I look at these rules right here, does everybody understand what it means? Understand what you're trying to optimize first. Okay? You gotta write down what you know, and then write down what you're trying to optimize. Okay? Sketches help. I'm not gonna lie to you about that. Try to make sketches. Alright? Step 3, then make sure you're always getting your formula that you're trying to optimize in terms of how many variables, if you can. One variable, and then basically step 4 is saying really do f prime of x, set it equal to 0 and solve. Okay. Now again, I would remind you, once you're done with some of those, strongly recommend that you go back and ask yourself or check what the question is asking, because if you don't, sometimes you get part of the answer right, but you really haven't answered the question completely. So be mindful of that, okay? All right, kiddos, let me stop this here quickly.